it is easy to calculate that 1 hour production is worth of tens of thousands of euros. So if with our system, in case of an emergency stop because of a failure or problem, if they can find a solution, get the production up and running again 15 minutes earlier, or half an hour, or 1 hour. So we are talking about serious money.
Hello, hi everyone, and welcome to Data-Driven Engineering Podcast. This podcast is about technology, how to improve how assets are run and designed, also maintained. Today we have an episode where we talk about how assets that don't have a 3D digital twin or a model can be digitalized. And today I have two fantastic guests with me. I have Antti and Jim. Please, can we just start with introductions? Can we start with you, Antti, who you are and where you're from?
Okay, so my name is Antti Kautto. I'm a laser scanning specialist at Elomatic company since 2021. And I've been in many projects in factory scale scanning and drone surveys and precision object scanning. So that's my specialty.
Right. Interesting. Great to have you here. And then we have Jim.
Hi there all, Jim Nyrus, Business Development Manager from Cadmatic. I have about 30 years career with 3D design applications, information management applications, and 3D is my passion, I guess same with Antti. And currently I'm working with our sales to find new customers related to our services and solutions for digitalization. And then I will try my very best to help our customers to take the most of those applications. And then one important thing is to deliver information to our development, how to improve those according needs of the markets and needs of the customers. That's my case now.
Good. Excellent. Great to have you both here. And today we're talking about how companies with existing assets that could have been built 20, 30, 50 years ago, which have mostly could have technical drawings and documents created, but then they don't have any digitalized models whatsoever. What would be the benefits of those, and how can these companies get to the next level? But before we go to that, perhaps, Jim, if you could just kind of in your words briefly describe what is a digital twin to somebody who doesn't know anything about that.
Well, that is a question. You would get different answers from anybody you ask for that one. But on my opinion, digitalization, digital twin, it's all about connecting digital's data with each other. So when you have different data, different facts, and you combine those, you get information. And information is something you do your decisions on, how to improve, how to solve the problems, and so on. So if you have separate facts, then you are not able to make good decisions. But when you combine facts, you have information.
Right. So a digital twin is enabling you to make better decisions, but also it's kind of, when it's digital, it's easier to share. It's everybody has access to that data more easily.
Exactly. That information is something what you can view from your computer, your workstation, laptop, and so on. So it's digital. So you don't need to go somewhere to see that one. It is in your hands, and that's important.
Now, of course, there's many different, levels or stages of where these different companies are it relates to digitalization, and somebody might be still working with paper documents, drawings, and whatnot. But what have you, Antti, come across in your work? You've been, really deeply involved in digitalizing these kind of assets. So what are kind of the situations that you traditionally go into? What's kind of the level where you usually start from?
It's pretty much both exist. There's a good 3D model maybe on a new building, but then there's the old buildings, and they might have paper drawings, or they might have no drawings at all. And even with the 3D models, if they are not accurate, our scanning may reveal something that even the plant owner does not know. So there may be mismatches or whatever you have in the plant, you can see in the scans. And in the fortunate case that you have a 3D model, you can start working together with those. So see the differences and start designing at your computer and not with a tape measure at the site.
And isn't that also kind of one of the challenges that these companies face, where, let's say, you might have something that is as designed, and then it's how it's built. So those things might be still kind of different. And as there's been, let's say, things that they've improved across the years, the assets keep changing. But Jim, how do you see kind of this difference between, okay, this is how it was designed, but this is what we have now, and how do you bridge kind of what you have in your drawings and what you actually exists?
Well, the most powerful combination of the 3D model is when you have the scanned model, where you can see in the point clouds how things are. And then if you have the 3D model, which has been created to build the stuff, so when these are combined, that's the most powerful things, because the scanned model, the point cloud model, is always accurate. It is how it is today. But then again, if you have a 3D model of the design, so the scanning doesn't see through the walls, so you don't see the pipes which are behind the walls and so on, inside the walls, inside the floors, which there are in the 3D model. So then you have the complete what is and what was planned. And in our solution, we can also compare the 3D model and the scans, so you can see the difference, what are matching and what are not. So then you are able to, if needed, to correct the 3D model according what is today, which you can see from the scans. And then there is also another case. We have a customer up north in Sweden who is doing a €1 billion project there, and they decided to do scanning every week while doing the construction. And we asked, why? They intend to follow up, what is the process of the project? So if they scan every week, it is efficient, and solution providers like Elomatic can do those kind of stuff very rapidly. So you can follow up the progress of the building, so where we are today and so on. And then you can also follow up the progress. Have we built this one as it was planned, comparing the 3D model and the scans? So there are plenty of use cases how to combine 3D models and the scanned model.
You mentioned this one project, but then there's probably quite a lot of other projects that you've been involved in, both with Antti, with Elomatic, and then us as a company. So can you talk about a few more examples, like the one in Sweden?
In what we have cooperated with Elomatic is, for example, in Fortum case. So there we have a project going on where they do scanning of such facilities where there is no 3D model. And we take them into our digital twin platform eShare and use the point clouds only and give them intelligence by putting those kind of smart points there, which is then connected to maintenance data. And the cooperation with Elomatic has been excellent, because then we can, before delivering something to the customer, we can ensure that these are now matching between their supply and our solution, so that customer can rely that this is now correct.
Right. Sounds interesting. So Antti, kind of how do you actually do the scanning? How do you do your work? As Jim was just explaining, kind of how good the collaboration is. Can you talk about a little bit of your role in a project like this?
So it usually starts by why do we need the scans? So there's usually a design project or a modernization or something, and usually it is some specific area, but sometimes it's the whole area. We want to have a general idea of the what is in there. So we may do a drone scan of the whole factory area of the buildings and maybe pipe routes and the surface. And it starts on the coordinate systems also. So we can have the scans in the plant coordinate system, and everything that is being added with the scans can be added to the same model accurately. And we can combine drone scans and laser scans, so from the exterior to the interior, all the plant floors, and that way start building the 3D assets from something small to bigger, or then the whole area at once. And there's a good example from a large paper mill where there's a good 3D model already that exists. And we started making 3D scans from one area and then added some other areas. And we found out that there is a mismatch inside the 3D model. So we found it by scanning the different areas, and it became apparent that maybe the 3D model in one specific place is accurate, but the buildings may not be accurately placed in relation to each other.
I would assume that the technologies have also developed quite a lot, the scanning technologies and all that. And I would assume that in some of these assets, it might be also really difficult to do small confined spaces versus sometimes you might have something elevated really high up. But can you kind of, from your perspective, how has the technology developed for the scanning?
When we started talking about laser scannings, the time that it took to scan something small, it was in hours to scan one place from one place something, and now it's transformed completely. Now we have mobile scanners that we can just walk around and scan an entire complex of buildings and get the information about, for example, the walls and the surface and pillars and pipes in general, to have a general idea of extremely large areas. And for terrestrial scans, scanners on tripods, we can still make much faster work than it used to be. So it's quite fast nowadays, and you get 360 panoramic photos of every place. It's like the teleportation of science fiction, and you can just visit the site from your computer.
Right. Yeah, that is really interesting. And so that kind of what you're also saying at the same time is that it doesn't, take months and years to digitalize an asset, but it's quite fast actually to do that with the modern technologies. And then you can take that created point clouds and the model and then transfer it to a platform like what we have with eShare, which is a digital twin platform then. So it doesn't necessarily need to take a long time to scan something. Then Jim, from your perspective, once you have that scanned model, how long does it take at your end to take this model and combine it with, let's say, a maintenance management system and PNIDs and whatever you want to connect into that?
That is actually pretty fast stuff. So when the point cloud or the mesh model or whatever Elomatic is providing or any scanning service company is providing, when that coordinates are matching with the 3D model, so then it just read that one in. That is fast thing. Then the other thing is to connect this dummy model look-like model of the point cloud. So if we have a shape of valve, for example, in the point cloud, how to connect that one, the shape only, which is not actually model, to maintenance management or documentation. So in our solution, we put a smart point on place of that one, which has the same ID as the real valve, for example, has. And then that smart point will be connected to the documentation, data, automation system, and so on. So that's our way to bring the intelligence to a dummy 3D model. Is it a scan model or mesh model or dummy 3D model produced from the laser scan? So same thing.
You also mentioned about this automation system. So you can have IoT combined so that the owner operator can actually see data related to that valve. And
yes, so we have different adapters, so we can connect that point or that actual valve 3D model, whatever. So we can connect those one to automation system through the OPC UA adapter. So from a valve, I can ask, are you closed, open, or something in middle? Or from a pump motor, I can ask, what is your RPM right now? What is the flow of media in one flow meter, and so on. So all those kind of things you can ask from the model, as we have linked that one to adapter to other systems. So that's no problem. We have to remember also that there are kind of two things why you do this laser scanning, as Antti said. So one thing is to someone has a need for the point cloud for the design purposes. Then you import that point cloud to 3D design application, as we have one also in Cadmatic, and then you create something new and avoid collisions in the current status and stage of the plant and use it for that purposes. Other ones are doing the scanning just to see how things are right now and make it as a base for the digital twin.
Yeah, I would assume that it really creates a lot of value if you can see the data contextualized in the 3D model rather than just looking at, data sheets or.
Yeah, true. In our point of view is that the 3D model is kind of user interface for the data. So you can visualize there with colors. So what is green is running, what is red is not running, old, new, and so on. Purchase, not purchase, if it's about the project phase, if it's about maintenance, so which shall be work needs maintenance next week after, what are the objects which has open maintenance request, and so on. So 3D model can be a user interface for all the data and also linked to the documentation. So I can ask from a pump, so where are your manuals? Please provide me those. Give me where you are in the process, PNID, what is your role in that one? Have you received the maintenance? Are there any open maintenance, and so on? So that will be a vital part of the digital twin.
It's kind of really interesting opportunity for many companies to do it in this way. So they have all the data, but then kind of how to connect these siloed data into one user interface, as you said it.
Exactly. We have different kind of examples how companies are starting with this. One of our customers, they have an old factory, old plant, which documentation were not up to date. So they started by that way that they scanned the whole complete plant and then let the external company create the dummy 3D model of that plant. Looks perfect, but has absolutely no intelligence. So then they took it to our design application, our design solution, and now project after project, they convert the dummy parts with the intelligent parts every time it's needed, and the intelligence grows there. And in addition, it is possible to add the smart points there if you want to have a linking from the objects which are not intelligent to the documentation and databases.
So in those cases, of course, you need a competent partner to do the digitalization, like Elomatic, what you're doing with some of your customers there. How many, out of curiosity, how many ongoing projects do you have, or how many projects have you worked on specifically?
Well, let me first say something about Elomatic, because we are a large company. There's over 1,000.
Please do.
1,000 people working for us. So the scanning team is just a small portion of Elomatic, and we do all of the plant design and process design, and we have marine and offshore and pharma. And so for the scanning team, our projects, we do around 100 a year, and it's a weekly basis operation, so we're doing it very frequently. We help our customers all over the world, so Indonesia, the States, I've been in Africa, in Tanzania, so all over.
But that's kind of when that situation is where you offer these services, scanning services, as part of the total portfolio of Elomatic. And as you said, of course, I would say most of your business comes from design and engineering projects.
Yes, and our specialty is as a scanning service provider is we are always linked to the design projects, so we know what and how to scan, so it serves the design.
The value that this kind of a combination of digitalizing existing assets and then having a platform that is really ideally suited for that kind of visualization of the 3D model sounds really, really interesting. You've mentioned, Jim, now Fortum and then some other companies, but isn't this more like, is it really specific to some industry or some types of companies, or who would be the ones who would benefit from digitalizing their existing assets?
Actually, any such facility or plant which are producing something, and when the production stops, they will lose money. If you think that like a pulp mill, besides the one part of the pulp and paper mill, so if the production is 500,000 tons per year, the cell and mass and or the biggest ones are more than 1 million. So it is easy to calculate that 1 hour production is worth of tens of thousands of euros. So if with our system, in case of an emergency stop because of a failure or problem, if they can find a solution, get the production up and running again 15 minutes earlier, or half an hour, or 1 hour. So we are talking about serious money. Or if the maintenance stop can be managed 1 hour faster or so on every year because of the decision-making power what you have when you have all the information in your hands. So then we are talking about serious money. And you don't have in your hands some old data because you are always reading the data from the very source, the owner of the data, like maintenance management and so on.
Some companies who kind of want you to combine everything and have everything in one place. And what you're saying is you're connecting to the data where it is. So you don't need to, take a document management system and replace it with something. You can connect to these data sources directly.
Exactly, that's what we do. So our digital twin platform eShare is not to replace any of these management systems. So we don't have replacement for maintenance management or document management or data warehouse and so on. So we read the data from the source when we need it. And that's why it is always right. So we are not a giant data storage which needs to copy everything for itself to be able to use that one. So we link ourselves, integrate ourselves to other systems and use those ones. And in the middle is the 3D model in way or another.
So that makes also implementation of a digital twin quite fast and easy because you don't need to replace any of your other management systems.
Exactly, and we have ready adapters which are common database adapters, REST adapter, or then we have product-specific adapters like we can integrate these easily with M files, document management, other examples exist. On the maintenance management, we have ready integration configurations for SAP or Maximo. We have a good cooperation with a Finnish company called Nexer within the field of Maximo and so on. So by the experience of more than 100 users of eShare in the industry, so we have gained kind of good coverage of these different applications what these industrial companies are using.
Somehow I came into this discussion thinking that, okay, this is only about existing assets and digitalizing them. But now I've learned that you can actually also use this during projects, and you can use laser scanning, even if it's a new build, that during the how many years that project takes, you can use laser scanning to make sure that everything is running smoothly, and it you can build that into the way of working. As an expert, what do you think are the next steps in this laser scanning technology, and where it will go? You said already that now it's really fast to do, but if you put your kind of thinking cap or this kind of industry expert cap on, and you think where this industry will go?
To me, having a laser scan versus having a model versus having nothing, having something always beats it. So if you have a project, you're usually on a schedule, and if something happens, if there's surprises, there's going to be a cost and delays. And if we have much more application of the scanning, so people will take use of it. We have less surprises, less extra costs, less delays. So I would just vision that much more of the scanning will be used in the future.
Jim, what are your thoughts?
For me, it is how to take the result what scanning companies or these technology providers like Elomatic is providing, how to make more of that one. So we recently developed an artificial intelligence-based solution where we can send a point cloud to inspection, where AI goes through the point cloud and recognize from there the tags which are on the valve or pipeline or on the tank or on the pump. So if there's a sign which can be visible in the point cloud or in these other formats where stands P123, so then we can automatically create this smart point on the plate, on the tag in the model with the name P123, and that will be then linked to the actual data of that P123 pump. So when we have the shape of the pump, so we can put the tag there and connect that to the maintenance management data and so on. So what would be probably next step is that instead that we only recognize the text from the plate, so probably someday there will be solutions where we recognize from the shape of the pump that is a pump and can replace the actual 3D model of the pump on the point cloud instead of the points which are forming the shape of the pump.
Yeah, I think AI is of course a hot topic in making waves in how industrial assets can be more efficient, and also the projects themselves. You mentioned this AI understanding that what the tags are. So you're saying it then makes it easier for that digital twin to be connected to. You were mentioning the smart points before, and you can manually add smart points, but AI would make that process much faster because it can identify.
It just wouldn't make it, makes it, because that is the reality already.
Yes.
So we can put those ones to recognize hundreds of these different text labels, and then we choose those ones which are correct one, because you can recognize also the WC sign from the toilet wall and we don't need the label on that one. So we recognize the labels which are matching the numbering system in the plant, and then we say that, okay, these are correct ones, these are valve position ID, so please put this smart point with that same name on those tag plates, and then we can link them same way as there would be a 3D model of the valve to the all necessary data and documentation of the plant.
It's possible to get 3D models with a text prompt from the AI. So there's not a big leap to teach the AI to see an image and then figure out what it would look like as a 3D model, and then compare those to scans or 3D models.
So I think that's a good place for us to stop for today. We have the next episode where we will be diving a little bit deeper into if you really want to have a 3D digital twin of your assets, and you would want to start from laser scanning and combining everything, how that kind of a project would be done in practice. So thank you, Jim. Thank you, Antti, for your time. Really interesting discussions. I certainly learned a lot. I hope that everybody else also learned a lot. I would recommend everybody to follow our podcast series. The next episode, as I told, will be about more practical, how do you create a digital twin? How do you really do the laser scanning? So thank you again, Jim. Thanks, Antti, and looking really forward to the next episode.
Thank you.
Thanks, my pleasure.